Continuing on with our discussion of inverse functions, example 3 asks, if f of x is x cubed a one-to-one function, find the following. Well, okay, first of all, let's talk about why this is a one-to-one function. X cubed, you should already know, looks kind of like this. And if we look at that graph right there, we realize that, yeah, it's a function. It passes the vertical line test. There's no one place where we can draw a vertical line and it crosses over the function more than once. But also, it passes the horizontal line test. There is no one place that we can draw a horizontal line and it crosses the graph more than once. Is there a way to check that without looking at a graph? Well, if we consider, I'm going to go a little bit out of order here. If we consider f prime of x, which is easy, 3x squared, one thing we know about 3x squared is that it's always non-negative. It's only 0 once when x equals 0, and other than x equals 0, this expression is always positive. And if the derivative is always positive, then our function is always increasing. Okay, well, if our function is always increasing, it can't ever turn around like that. It's that turning around right here that breaks the one-to-one part of a function. So if we never turn around, if we don't have any relative maxes or mins, then our function should be one-to-one. Right? So yeah, we are going to have an inverse function here that represents the entire original function. So f of 2, that should be very easy. We know that 2 cubed is 8. We also know that f prime of 2, well, that's also easy. 3 times 2 times 2 is 12. All right, so these are some basic questions about the original function. Now let's just take a look at the inverse function. Well, the inverse of x cubed is the cube root of x, because that's what undoes cubing, right? Cube roots and cubes are inverses of each other. So what is the inverse of, or what is the derivative of the inverse? Well, this is the same thing as x raised to the 1/3, so a quick power rule tells us this is 1/3 x to the negative 2/3. Or, if you prefer, you can write it as 1 over 3 cube root of x squared. All right. So now we're going to ask about what is f inverse prime of 8. Why 8? Do you guys see any reason why we would be talking about 8? Well, the input of our inverse function corresponds with the output of our original function. So we already have some information about f of 2 and f prime of 2. We know what's happening with the original function at x equals 2. So what we want to do is we want to compare the properties of the original function at x equals 2 with the inverse when y equals 2. In other words, when x equals 8 over here. So f inverse prime of 8 is going to be, well, we'll just put in our 8 into our expression down there. We get 1 over 3 times the cube root of 8 squared. And the easier way to do this is cube root first and then square it. So cube root of 8 is 2, 2 squared is 4. We get 1 over 3 times 4, or 1 over 12. Okay, but what about, what is the reciprocal of f prime of 2? Well, if f prime of 2 is 12, then 1 over f prime of 2 is 1 over 12. Notice that f inverse prime of 8 is the same thing as the reciprocal of f prime of 2. Or more generally speaking, if f of a equals b, then f inverse prime of b equals 1 over f prime of a. The two derivatives are reciprocals. Make sure that you're plugging in the output for the inverse function and the input for the original function. So that's fairly key. Okay, so that's the basic formula that we're looking at here. So you might look at this quintic, this degree 5 polynomial, and get a little bit nervous because you don't know how to find the inverse of that. Well, rest assured, neither do I. This is a problem that we don't actually find the inverse like we did up here, but we're just going to use this property that we just learned. So first of all, we're going to use f prime of x and the fact that this is a continuous function to show that this is 1 to 1? Well, let's take a look. F prime of x is 5x to the 4th plus 2. And this is greater than 0 for all x. Right? Upside down a means for all. So no matter what x I put in here, I'm going to get a positive derivative. So f is always increasing. So f is 1 to 1. All right. So what about these next two questions? F of 1. What is f of 1? Well, f of 1 equals 1 to the 5th plus 2 times 1 minus 1, or 1 plus 2 minus 1 is just 2. So what does that have to do with finding f inverse prime of 2? Remember that we don't want to plug this 2 into here. We don't want to plug this 2 into here. This 2 is an input into the inverse function, which means it's an output in the original function. So if this is to be believed, which I think it is, we know that this is going to equal the reciprocal of no longer the inverse, but the original function's derivative, not evaluated at 2 because 2 is the output, but rather the input that's associated with that output. So 1. Okay? There's only one input that's associated with 2 because f of x is 1 to 1. So we know for sure that f inverse prime of 2 is equal to 1 over f prime of 1. Well, f prime of 1 is 5 plus 2, or 7, so our answer is 1/7. Very cool. All right, so we can look at this in a very abstract way and not even know the functions themselves. Just know that they're inverses. M and n are inverses of each other because their composition is x. And we know that if we plug in 5 into m, we get -9. Which is exactly why we're plugging in -9 into n. Okay, so if I asked for n prime of 5, I wouldn't have any information for that. But since I'm looking for n prime of -9, n prime of -9 is the same thing as the reciprocal of m prime of the input that's associated with the output of 9. Well, the input that's associated with the output of 9 is 5. Therefore, we just have to take the reciprocal of m prime of 5, so it's just -11 over 8. And that's all it is. All right, and then this is a very common way of asking the question. It's the same sort of deal. It's just giving it to you in a table. Again, they're inverses of each other. So if I want to find g prime of -3, do not look at that. We don't care about that at all. That's a distractor. We want to say, okay, well, that -3 is an output, so that means that f of x equals -3 when x equals, well, we have to figure that out, right? F of x is right here, and that happens when x equals 7. All right, so don't use -3 as the input for f because -3 is not the relevant input for f. 7 is the relevant input for f. So when we find g prime of 3, we're actually going to find f prime of 7. F prime of 7 is 2, so that means that g prime of -3 equals 1 over f prime of 7, which is 1/2. Fun stuff.